Excellent. Hello, everyone. Thanks for joining to the part two of this CloudOps workshop. So, continuing on today's agenda or topic, we'll be discussing networking, DNS, and then we will be doing a demo on some useful and specific commands that they are used day to day, or at least in the part of troubleshooting in terms of CloudOps and DevOps and cloud engineering related tasks. So without further ado, let's jump in right into networking, right? So in here we can see a small diagram. I'll explain it, just so we can be on the same page in terms of what is networking and how specific packages go around our entire networks. So in a nutshell, networking is just the practice of connecting computers, devices, or systems together in order to facilitate like communication, data exchange, and resource sharing. In a network, individual devices, or in this case, nodes, as they are technically referred as nodes, are linked to one another through various methods and different technologies, right? Different protocols that we'll also be reviewing during this course, allowing them to interact and share information, right? To exchange, at the end of the day, information and resources. So in here we can see like a local network. So a local network is literally just covers a small geographic area. Normally this tends to be like an office, like a regular coffee shop, your regular Starbucks when you go for a coffee and start working from there, or even your home, right, from where you are connecting right now. So in here you can see like the main components that any single architecture in a network will have, that you will have in this specific case, like a cloud in here is called like the internet service provider. This is the company you will normally pay for in order to get the internet, and access, the internet. This is done via, they will provide you like this specific router or modem, as we normally call it. And this is the modem that will connect and authenticate into the service provider. And then you will then be granted like a public IP address. And this is important as well because you will have like a public IP address, and this is the address that you will be, going out through the internet and reach out to websites like Slack, Google, Facebook if you are doing Facebook, and then you will have that will be your public IP again, and then you will have like your internal IPs in your network. Again, we will not go into full details of how they are assigned or created, but in a nutshell, you will have all your nodes here or your devices. You can see your laptop, your local computer, your printer, a brand new PlayStation 5 apparently here, a cell phone, and another computer. So every single device in here will be assigned automatically, given a protocol, an IP. So as you can see, your computer gets the same 192.168.0.101, whereas your computer gets 104, and therefore, that's the way all these devices can get an internal IP, right? This will be called an internal IP, whereas in here we're talking about a public IP. This will be tremendously important when we start working with the cloud, on where we will need to, validate and differentiate, what is a public IP and a private IP. So yeah, this will be like your regular, local network that you have currently on your computer, on your home right now, for example. So this is like, for example, if you try to reach from your computer Google, you will get from this local IP into your modem, and that modem will send the request to the internet service provider, and we using this specific IP, right? So now let's jump into a more complex, and also like this diagram explains how your computer does the petition into Google or any other server as well. Again, there's a lot of moving parts in here, and we'll try to just be talking about the most important ones. In here, you can see that the step number one, like for example, you enter in your browser packetjourney.com. In this case, let's say suppose it's admin.com. Normally, what will happen then is the second step, it will be a DNS lookup, and we will just discuss that in the next slide about DNS. And that DNS will just translate package journey or admios.com into a regular IP. As you can see, it will do all these jumps in here into the DNS servers that we will also review in just a sec. And then it will get like a specific response that packetjourney.com refers to this specific IP, right? The public IP 54 and so forth. And then your laptop will be able to go, into your local modem and then go that specific, with IP, the public IP, into the request to the internet service provider, and then the service provider is the one doing, all the magic, I will say, in order to connect you from your local computer into the internet. Soon after, you will be connecting right into the internet, into the World Wide Web, and then you will be accessing directly with this public IP that is, worldwide, accessing this specific load balancer in here on AWS, and that's the one that has the actual web server, right? So then you will just receive that package, and you will be able to like see the actual website or website on your computer, right? So in a nutshell, this is how packages flew around the entire internet from your regular. As soon as you press enter on your browser, what happens next? Normally, all these steps will happen in just milliseconds. So milliseconds in terms of doing the request, resolving the DNS name, and then you just reaching out to the server that hosts the application, right? Then, of course, in terms of performance and what the server is responding, you might have some more time in order to see that website, right? Like 2 or 3 seconds in order to all the website to load on your computer. But in terms of networking, this happens in milliseconds. So now talking about DNS, this is also really important because when working on cloud, when working as cloud engineers, DevOps engineers, and so forth, most of the time issues appears when you're trying to debug something related to the internet, to a package, right? Our job is to like maintain websites, like developers deploy your applications, and then you will expose your application in a DNS name, right? In this case, like example.com. So your website will be hosted on example.com, and just as a heads up, we will be doing that in the next weeks, deploying a full website and having it production ready, doing all this DNS setup, using AWS. So in terms of that, this is the actual DNS itself. It stands for Domain Name System. It's really, really an old system that for today is still, like I would say, the base of the entire World Wide Web and how we communicate and share resources within computers, servers, and nodes. And it's a fundamental technology at the end of the day, right? It's used to translate human readable domain names to Internet Protocol IPs, right? So in this case, instead of you typing, the entire IP of a web server or a page you want to access, you just type example.com, admios.com, facebook.com, and then that specific service is the one that will translate that into just IPs, because that's how the internet works and servers works on. They are assigned IPs, and that's how they are being able to reach. So in terms of knowing how exactly this works, again, this is really important because it's something that we need to know in order to, for example, deploy a new application, in order to create a new website. So number one, the end user will type in your computer example.com. So then, the second step, it will go into the DNS resolver. This is normally a DNS resolver that you have over your modem. It will point to a DNS resolver. Normally, we use the Google one, the 8.8.8.8. There are some others as well, but that DNS resolver, it will be in charge of translating that domain into the public IP, into the IP that we need to reach. So it will go number 3 to the DNS root name servers. These root name servers is the type of server that hosts like the root domain names. In this case, the top level domains, it's called. You can see the top level domain as .com, .net, .org. Those are the root domains, the top level domains. As soon as that information is got, it will then jump again into the name server for .com, the top domain level. And here we will have the example. In this case, we can see the domain that has www.example.com. Again, the example is the domain, www is the subdomain, and .com is the top level domain. So as soon as we got, we reach out to the name server of .com, we will see that example.com is hosted on Route 53. Route 53 is the DNS registrar that is owned and managed by AWS. So it's like your regular, GoDaddy, Namecheap, Cloudflare. These are all services, companies that offer you the possibility of buy a domain and then host the domain, right? So in this case, example.com is hosted on Route 53, again on AWS. We'll be seeing this in more details in the upcoming weeks. And soon after, we will get that example.com goes directly into Route 53 name servers. And in here, it will resolve, oh, yeah, www.example.com points to this specific IP. This IP is the one that will be resolved and returned into our computer. So, at the end of the day, example.com, it's equal to this, IP, and this is the entire process that package has to jump around in order to just get that value, right? Soon after, you will just go to example.com, and that will point to this specific web server. That's the web server with that specific IP. And then I will send just the package into the end user, and you will be able to see the web page, for this specific server, right? So that's how exactly, the DNS works, and how packages are translated, and which specific root servers and name servers have to exist in order to, being able to resolve that, right? So in terms of cloud operations, one of key components of this is managing, or Amazon Route 53 name servers. If you're using GoDaddy Cloudflare, you will then be managing this specific part of it. These two are literally managed by some other entities, but this is the part that we need to manage in order to create resources and so forth, right? So that's it. We will now be jumping into some specific demo with Omar. In here, we'll be running some specific commands that Omar will be showcasing. So without further ado, let's give a warm welcome to Omar.
Hey guys. Thanks, Andres. So yeah, like you mentioned, we're going to be running today some very useful commands, networking commands that we can use to maybe troubleshoot some of the very common and basic issues on our networks. And then we're going to go back into bash scripting, right, to introduce some more concepts on that. So I am going to take over the presentation now, and we are going to go into our bash console. Great, and we're going to start running some commands, right? So the first command we're going to look at today is going to be the DNS lookup command, ns lookup, and this is going to basically allow us to check what is the IP address resolving for a specific DNS. So that is going to hit a DNS server, and or a DNS server in between that has that information cached, and that is going to give us back what is the IP address that resolves for it. So in this case, it's telling me that google.com resolves for 142.250.217.164, right? Next, we're going to take a look at the ping command. I'm pretty sure that you guys are pretty familiar with ping, and that is going to check if we can reach a specific destination over the network. So we're going to ping Google, and as you guys can see, we're hitting Google just fine. We can also fine-tune ping to do to act differently in some ways. For this, we're just going to introduce one flag, which is the C flag. That is going to let us change how many packages we send over the network. If we don't, we're going to let it run, infinitely. So we're going to say, I want to send 5 packages to Google. And that is only going to run for 5 packages without me having to kill the process. We're going to clear that. And OK, next, we're going to take a look at telnet. This command was originally used to connect to mainframe computers and basically control them. But now it's kind of used for diagnostics, just as ping. This is going to let us check if we can reach a particular host over a port. So for example, we can try and hit Google over the 443 port, and and it says connected to Google. So that let us know that we actually the test was successful. If we couldn't, there will be an error. So we're going to cancel that. Oops. Next, we're going to take a look at the curl command. So this is going to basically help us exchange data between 2 devices over the network using the command line. So that is curl or curl, I guess. And we're going to try fetching admios.com, right? But because that is a web page, and of course, the command line is not going to handle that, we're just going to use the uppercase I flag to only fetch the headers of the response. So we're going to hit Admios. Oh, let me just paste the proper. Right, we hit that, and we see that we get a 200 successful response, and we see that the content type was actually going to be HTML, right? And we see all sorts of headers for this request. Of course, we can hit a proper endpoint using this, a proper API endpoint over HTTP. And we can do that using curl. We can hit that. And that is a basic query to a weather API querying for Panama, right? And we can see we got JSON response as we used to, but this is not very human readable. So we can take the output of this command and pipe it into another, right, using the pipe operator. So the pipe operator is going to allow us to basically take the output of one command and redirect that into the input of another. And we can use that to chain commands. It is very useful, right, if you want to like do operations one after the other. So for this case, I'm going to use JQ, I'm sorry. That is a lightweight and flexible JSON processor. You guys can download this. This is not native to Bash. And once I run this, I'm going to get the same output, but formatted into JSON, right? Pretty useful if we just want to test on the console using curl. I'm going to clear that. Next, we're going to take a look at the ifconfig command, interface configuration. And that is going to let us see all of the network interfaces on our current host. So for example, this is a Mac computer. So besides the LO0, which is the loopback for a local host, we can also see the N0, N3, etc. Those are like Ethernet connections. They show up as N0 in Mac. If we scroll down, we can also see some bridges. We can also see the interfaces for AirDrop, for example. But yeah, that is going to let us see all of the current interfaces, active ones, on our current host. We're going to clear that. And for the last one, we're going to run the traceroute command. So the traceroute is basically going to allow us to check what are the different hops a package takes to get to a specific destination, right? So for this, we're going to do NS lookup first to get that Google IP address because I didn't write it down. Clear that, and we are going to do trace route to Google. And we're going to start seeing that, just as Andres mentioned, right? This is my local computer's IP address on my local network, and then it's going to hop into the ISP provider's public IP address, and then it's going to continue to hop along through the network, through the internet, until it gets to Google, right? And we see it also does some domain name resolutions and stuff. Whenever traceroute does those DNS resolutions, it can take a bit longer. If we don't want to do that, we can send in the N flag, right? That is going to tell traceroute not to do that. Just a second. Yeah. So we're going to run this. And now we only get IP addresses for this. And yeah, we're going to let it run until it finishes. Yeah, but after this is done, we're going to jump back into Bash scripting. Cool, it's done. We're going to jump back into Bash scripting. And for today, we have two examples. We're going to close this for the time being. And we're going to open this one. So for the first example, we're going to make an IP scanner. So given a range of IP addresses, we're basically going to ping them and see which ones are available within that range, right? So we're going to start coding the script. Always remember, of course, the shebang and then the route to your Bash executable. OK, so first of all, because we don't want to be, running basically hard coding that ping and echoing that later on, we want to make a function for this, right? So functions in Bash can be declared pretty much like in any other programming language. We can use the function keyword, then declare what is the name of the function, parentheses, and then curly braces for the body. Bash also allows us to basically omit that, and I'm going to do it. And for this function, we're just going to do something very basic. We're going to basically check if the ping command is successful or not for any specific IP address, right? And we're going to pass in that C flag that we saw before because we only want to send one package. We don't want to overwhelm my local network. And then W to set the waiting time for that. And we want to set that to 1 second as well, just to make sure that we can reach those things. Now, you guys might be wondering, how do we pass arguments to a function? So functions function calls work pretty much the same as if we were calling a command from the command line. So function arguments don't need to be specified here. They're just passed in, and we're gonna see that later. So right, so the first positional argument for a function is gonna be $1, just as is passing arguments to a command, right? And that is gonna be the IP address we wanna check. And because we don't really care about the output of the ping command in terms of like standard output or standard error, we're gonna redirect those to like a Unix void because we don't really care for that. So to do that, we're gonna use ampersand and right angle bracket. Basically, this is gonna tell Bash to take the standard output and the standard error output and redirect them into the def null. So this def null is like a garbage. Whenever we don't want the output of something, we can redirect that there. So then, if, of course, the ping is successful, we're just going to echo that that IP address is active. Cool, and we're going to finish our function. I mean, our close the if statement. Cool. So we've said that the input for this script is going to be an IP range, and we're going to save that into a variable called block. And we're going to kind of assume that this is going to be the format of the for the script. So we're going to assume that the last octet is going to be, quote unquote, is going to be the range of hosts, and then everything before that is going to be the prefix, or kind of like the mask of the network, right? And so that's what we have here, right, from the arguments passed in. So then we're going to do, right. So next, we basically need to extract from this all the data that we need. We need the prefix, and we also need what is the start IP and the end IP. And we're also going to assume that this is, the start IP is going to be less than the other end of the range to save us some validations. So we're going to echo the block variable, and we're going to pipe it into a new command, cut. So cut, as the name implies, is going to allow us to basically split a string into substrings based on a delimiter. So for this case, I'm going to split it based on the period, right? And using the F flag, we can choose which field, meaning which substring resulting from that cut, right, we can choose from. So if we do that, it's going to be 1, 2, 3, and 4 fields. So I'm going to take the 4th field, and that is going to be the range, right? And similarly, we can say I want my start IP to be, we're going to echo range, right? Pipe it into cut, and very similarly, I'm going to set the delimiter to a dash, and I want the first field, right? We can copy this and do the same but the second field, right? So now I have my start IP, my end IP, and so the only thing that I need is the prefix. So I'm going to say prefix is going to be equal to, we're going to echo that same variable block, right? We're going to pass it to the cut, and we're once again going to cut it using a period delimiter, right? But this time, we kind of want the first, the second, and the third fields, right, joined together. So we can let bash know that we want this, doing this, basically saying, hey, I want the first field through the third. And that is going to bring us back these three fields joined by the delimiter. Cool. So now I have all that I need to start checking for those IP addresses. So we're going to iterate through those start IP address until the end with a for loop. So for that, we're just going to say for. We use double parentheses to set the statement for loop. And then we're going to say I is equal, to start IP. Pretty similar as to how we would do it in another language, in other languages, right? To the end IP, right? Oops. Plus. Semicolon then. And then in here, it's where we are going to be calling the function we just defined, which is check IP, right? And like I mentioned, this is basically like calling a command. So the arguments for this are not, defined in parentheses. We just need to like set them here, right beside it. So of course we need the prefix, period, our I, right, to get the whole IP address formed. And at the end, we're going to add an ampersand. Basically, this ampersand is going to tell bash to run this function, but in the background, right? So it doesn't block the execution of our script. So we can continue looping, and then all of that is going to be run in the background, and we can continue checking for IP addresses. Because, I mean, of course, in this example, we're going to check for like 200 IPs, but it could be more, and we don't want to, overwhelm stuff. And at the end, to finish this up, we're going to do a wait, basically telling bash, hey, wait for all of those background processes to end. And OK, now we're going to run the script. So we do sh scan.sh, and I'm going to run this on 192.168.0.100 to 200, right? And great. Let's see that very quickly. Oh, of course. Not a then, that is for ifs. Cool. And as you guys can see, it's going to take range from 100 to 200, and that is going to ping all of those. And this one's here are the ones active on my network. So it could be my laptop, could be my phone, could be my iPad, whatnot. Cool. So moving on, because it seems like we've gone over the time, we're going to look at the next example. This one is, again, pretty straightforward. Remember the traceroute command we saw before? Well, we are going to take the traceroute command just as before, but we're going to format the output of that. And for that, we're going to introduce a command called awk. So awk is basically going to allow us to, from a text source, do some pattern matching on that file, and then format the output based on that pattern. Okay, so just as before, we're going to take a destination IP from our arguments. Then we are going to run the traceroute command, but instead, we're going to save that into a variable. So this is going to save the whole output of the traceroute into our traceroute output variable. And then, we're going to echo some headers. And now we're going to do the formatting, right? So first, we're going to echo this variable so that it's on our standard output. We're going to pipe that into the awk command, which actually, by the way, awk stands for basically nothing. It's just the names of the people that created the command. That is Aho, Weinberger, and Cunningham. Fun fact. But anyways, the awk command is going to take an input, encased in single quotes. And the first thing is going to be a pattern that is a regex, right? So I've prepared a regex here for this example. And basically, this is going to take from the traceroute output for every single line, it's going to try and match which lines have hop numbers, right? And then followed by an IP address. And then in curly braces, we can set our program or mini program for pattern matching, for formatting, right? So we can create variables inside this environment. We can say hop is equal to $1. And this $, just as in the cut command, is going to mean the fields from our output, right? So let me trace route. Oh, let me just go back and run the trace route again, right? So we're going to match these type of lines, right, that start with a hop number. And then just as in the cut command, this $1 is going to be the fields, right, from these from this line. So by default, it's going to have a delimiter of white space or tab. So we're going to have 1, 2, 3, 4, 5, etc. fields. So $1 and so on are going to be those fields. So because we know the first one is the hop number, we're going to do that. Next, similarly, we're going to do semicolon at the end. Next, we're going to do the IP address because we know that's the second one. And lastly, we're going to do the response time. Now, for the response time, because we know that's the last one, but we don't want to count, we're going to use a special variable that AWK exposes to us, which is the number field, right? And we're going to do number field -1. And even though we start counting at 1, there is a $0, and that is for the whole line that matched the pattern. Lastly, we're going to do print, which is the output for the AWK command, and we just need to print our data, right? We can save that. And now if we run our sh trace.sh, and right, do need that. We're going to see the new format. So that is going to take some time because it's going to save all of that output into a variable. And after it has done that, AWK is going to process the output into our desired format. Cool. Right. And as we can see, we have our headers, hop number, and then the response time. And we don't have that whole thing from before. Cool. So that completes the short demo on Bash 101 that we have prepared for you guys. So we can go back to the presentation and do the QA session. Thanks. Yeah, so if you guys have any questions, you can tell us or write it on the chat.
Yeah, AWK, for example, that's used more or less for filtering around columns, right?
Yeah, I mean the pattern matching is gonna go through the whole line of a text. So for example, if you have a file with 20 lines, that pattern is gonna run through each line. And then the output for that is going to be in columns, like you mentioned. Those are the fields.
Thank you.
In the last example, you mentioned about something about the NF. What's that?
NF? Okay, so NF is a special variable that AWK exposes, and that is the number of fields. So in other words, like the number of columns resulting from the pattern matching and then from taking into account that we're using the default separator, so white space. So that is going to break it into like small tokens, just like in the cut command. And that is the total number of fields or columns.
All right. Thanks.
Okay, cool. Do you guys have any other questions?
So yes, if there are no more questions, I think we can leave it here. Next session, we will be start talking about the DevOps mindset, DevOps culture, CloudOps, and all these topics related to cloud. Just for the roles of DevOps and cloud engineering. So yeah, thanks for joining and thanks for your time. So see you on Thursday.
Bye. Thank you.
Thanks, everyone.
Right.
Thank you.